So what if you are given, you are asked to calculate number of moles or number of atoms or number of mass of an element in a compound. So we have a compound and then you want to determine the number of atom of that element in the compound. For example, we have calcium carbonate, CaCO3, and then, for example, if it is 3 grams of calcium carbonate, and you are asked to calculate number of calcium atoms in 3 grams of calcium carbonate. How do we do the calculation? So let's go ahead and see how we are going to do the calculation. So we have all these steps here. We have this, I simplify it here by giving you these 5 steps. So the first step is to determine the molar mass of the compound and then determine the number of mole of the compound. So instead of reading the steps, we will look at this question and then we will be revising the steps one by one. So the question says, calculate the number of atoms of oxygen in 0.2 kilograms of sulfuric acid. So that is the question. And how do we go about answering the question? So if you go back here, the first step is to determine the molar mass of the compound. So we want to determine the molar mass of sulfuric acid. Remember, to calculate molar mass, we just add up all the masses of the substances or the elements in the compound. So we have 2 atoms of hydrogen multiplied by 1 plus 1 sulfur. And then, so sulfur is 32. Let me just plug it in directly. 32. And then plus oxygen, we have 4 of them, and oxygen is 16. So in this case, we are going to get 98 grams per mole of sulfuric acid. So this is the molar mass of sulfuric acid, and that is the first step. The second is to determine the number of moles of the compound. So we convert the molar mass to mole. So to do that, remember, number of mole equals mass over molar mass. What is the mass? It is 0.2 kilograms. We have to convert it to grams. Don't forget that. 200 grams divided by 98 grams per mole. And that will give us 2.04 moles. 2.04 moles of sulfuric acid. So we are done with step number 2. So let's look at the third step. Determine the number of moles of the element in 1 mole of the compound from the molecular formula. So what is the number of mole of the element in 1 mole of that compound? So the molecular formula is H2SO4. H2SO4. 1 mole of H2SO4 contains how many mole of which element are we calculating? Oxygen. How many moles of oxygen do we have in this? So you just calculate, you just count this. O is what? O4. O4. So it means 4 moles of oxygen. 4 moles of oxygen. So that is how to go about it. So ratio 1 to 4. So that is step number 3. Now, determine the number of moles of the element in n moles of the compound, which is easy now. So we know that 1 mole of the compound contains 4 moles of, 4 moles of oxygen. So how many moles? How many moles of oxygen are we going to get in the calculated mole here? Which is n mole. Remember, n is n here. Is 2.04 mole. Remember, that is easy. If 1 mole contains 4, so that is 2.04 mole of sulfuric acid, what we calculated here, will contain what? Will contain what? Will contain X. If you do your cross multiplication, X will equal to 4 times 2.04 mole. We're just breaking it down. Since it's ratio 1 to 4, if you multiply 2.04 by 4, you are going to get the number of mole of oxygen. So it means we have 4.2.04, so which is 8.16 mole of oxygen. So we get number of moles of oxygen now. Remember, where we are going is to calculate the mass of oxygen. Sorry, our aim is to calculate number of atoms of oxygen, not the mass rather. So let's look at the step we are now. So we are done with this step number 4. So we are going to be going to the last step now. So number of atoms now. Since we know number of mole of that oxygen, the next is just to use N equals number of mole times Avogadro's number, which is N of A. And the number of mole that we got for oxygen is 8.16, and the Avogadro's number is 6.022 times 10 to the power of 23. And what is going to be our final answer? The final answer will be 4.91 times 10 to the power of 24 what? 24 atoms of oxygen. So that's the question. Calculate number of atoms of oxygen. Again, how do we do that? It's easy. Get the molar mass of the compound, and that's what we did here. That is step number 1. After that, from the molar mass of the compound and the mass of the compound, get the number of mole of that compound. That's what we did here. So, and then we are going to the atom we want to calculate now. We are going to use ratio. We know that from the formula here, H2SO4, this is 1 mole of H2SO4, 1 here. And that 1 mole of H2SO4 contains how many oxygen? It contains 4 moles of oxygen. For sulfur, it contains 1. For hydrogen, it contains 2. So we are looking for oxygen. So if 1 mole of sulfuric acid contains 4 moles of oxygen, this is the value that we get here, which is 2.04 mole. 2.04 moles of sulfuric acid will contain how many moles of oxygen? It will contain 8.16 moles of oxygen, because we are going to multiply 4 by this value because they are in ratio 1 to 4. That is how we got number of moles of oxygen. When you get number of moles of the atom, just convert it to number of atoms using this relationship. So, and then eventually we get 4.91 times 10 to the power of 24. So let's try one more calculation regarding that. We are asked to calculate the mass of iron in 1 gram of limonite. And limonite is what we see over there, Fe2, that is iron 2 oxide, 1.5 hydrate. So that is where I will say it. That should be okay for us. So remember, the first step is to get the molecular mass of this compound, or formula mass of this compound. So Fe2, 2 times 56 plus 3 oxygen is 16, and then plus 1.5 big bracket, 1.5 big bracket, 2 of hydrogen plus 1 of oxygen, which is 16, big bracket. So 2 times 56, if you do all this calculation, eventually you will get 187 grams per mole. That is what you're going to get. So that is the molar mass of limonite. So we get the molar mass, we will convert the molar mass to mole. That is, we want to calculate the mole of the substance from the molar mass. We know that number of mole equals mass over molar mass. And the mass is 1000 grams. Remember, 1 kilogram, you have to convert it to grams. 1000 grams divided by 187 grams per mole. and eventually we are going to get 5.35 moles. So that is number of mole of limonite. Okay, that's the calculated mole. Now, we are looking for the mass of iron. So, and iron is 2, Fe2. So it means 1 mole of limonite, that is Fe2O3, 1.5 H2O, contains 2 moles of Fe. So we got the mole of Fe. This is we get this one just from the formula. So there's no calculation there. Now we want to calculate. So how many moles of this? How many moles of iron we are going to get in 5.35 mole of this will give us what? To give us 5.35 times 2 divided by 1. Remember, or if you are confused, because I don't want to confuse you, I can just put x here. We can put x here and then we cross multiply. So x will equal to 5.35 times 2 divided by 1 mole. Remember, this is 1 mole. And this is also mole. Let me clear this so you understand it. So this is 5.35 moles times 2 moles. So eventually we are going to get 10.7 moles. 10.7 moles of iron. So we just convert, we get that one in mass now. So we've gotten the mole, number of mole of iron in 1 kilograms of limonite. So the question is calculate the mass of iron in this. So we get mole. Remember, number of mole equals mass over molar mass. Small letter m and capital letter M. For the mass is small m, and for the molar mass is capital letter M. So let's put it. And we want to calculate, we want to get mass, not the mole. So it means we can rewrite this in terms of mass. So let me just put it. So it's going to be mass equals, it's going to be mass equals number of mole times molar mass. And what is number of mole? We got 10.7. And what is the molar mass of iron? I think we had it up here. So given here is 56. And the final answer will be what? It's going to be 599.2 grams. You can round it up to 600 grams of iron. So that is how to do the calculation. So we're going to meet in the next stage of these calculations. Thank you and bye-bye.